Hello, my name is Jamel, and then I'm going to be presenting the forecasting retail sales and predicting house pricing using machine learning. Basically, it's like a dual project combined here using machine learning and time series for retail sales and advanced regression technique for the house prediction. So the presentation overview, we will talk about the store sale forecasting, which analyzes like the time series through ETS and then area models. We're gonna like explore the data by season stationary check and then pre-processing steps. On the second part, we will talk about the house pricing prediction, which is basically advanced regression and then also the future engineering. And then at the end, the model will be evaluating by comparing the performance, and then key insights. So the project introduction. So as I mentioned, we will explore basically on the time series forecasting. We explore the sales prediction for grocery items using temporal data patterns. So we're gonna look at the patterns, and then also we're gonna use the ETS and the ARIMA approach for optimal forecasting, basically the projection, how the price will be. And then on the house price regression, we use basically advanced technique to predict the residential property, from using different like features. And then we're gonna compare the methods such as like regression and random forest models. So for the store sale forecasting, the objective basically, as I mentioned, was forecast the grocery sales in the store using time series, the data sets we use basically like the data set that was provided in Kaggle. 7 files included sales, store, product information plus economic factor, and then we capture that through ETS. So how do we explore basically like the data? So we actually selected like the grocery in store one. We categorize some of the variables for manageable analysis, and then we look at the daily sales to identify the pattern basically. And how did we visualize it? We The data basically showed a strong seasonality and then a potential trends, which was actually a good sign. And then there was a daily fluctuation that shows weekly shopping patterns. So why do we actually have to pre-process the data? So for manipulation purposes and then accuracy, so we have to do that because that's part of like the data science procedure to avoid like error and increase accuracy. So that's why we look at the set regular daily frequency of consistent analysis basically. So stationary analysis, so we started with like initial assessments. We apply the Dickey-Fuller test, which actually confirm the check for stationary. And then the cells was actually original. And then we basically like employed the differencing application, which was the first order differencing to remove the trends and then transform the data, which shows a stable mean and variation property. So to verify that it was actually accurate, we run a case that it wasn't like there was no differencing in the trend. So it confirmed again that our data set was actually accurate, which was a good sign actually. And it's a good habit to do that because it's important in the analysis. And then the time series modeling, after confirming everything was actually good to go for the modeling exploration. So the ETS models basically was exponentially smoothing, capture the trend and seasonal patterns, and implementing like with a seasonal period of 7 days, which was actually good. And it optimized basically the parameter the data and the parameter using the maximum likelihood estimation. And the best ARIMA models that was actually captured by was the ARIMA 510-2007 with the time approximately 130 seconds, which was actually pretty good for you know our modeling. And how did we evaluate the model? So here we use like the MSE and then the MAE. As you can see here, the ETS has more MSE compared to ARIMA, which supports, our confirmation matrix across both measures because the ETS basically like outperform. So a lower MA indicates better prediction accuracy and extreme error, as you can see here, compared to the ARIMA. And then the time series insights. So we run again like a residual quality and to actually just look at the minimal autocorrection, and then that was actually a good fit to just show that okay, our evidence was accurate. So there was no evidence of overfitting observed during our diagnosis check, which again strengthened our reasoning and conclusion. So that was basically like the end of the first part. And then the second part will introduce like the house pricing prediction. The goal is to accurately predict the house price, the house sale pricing. And how do we evaluate that? We use the root mean square error on the log transform prices. And then we use basically the techniques such as advanced regression with feature engineering. So the way we proceed with that was actually enumerated here with like, a data preparation pipeline where we actually combine both the testing and then the training sets for just consistency purposes to just avoid like, error and stuff like that. So once that was done, we actually proceed with like handling the missing value because sometimes we receive like, data sets that contains missing values. So in order for us to ensure our analysis was actually correct, we actually check again for the missing values to basically like increase our accuracy. And then once that was done, then the log transformation, we talk about look at the distribution and how stable the variance was, and conclude with the feature engineering to like encode different category variable and polynomial interaction. So we realized that we had a regression of like 0.0123, and then the mean absolute error of close to like 0.7%, which was actually we mitigate basically like reduce basically like multicoloring, so the interaction basically of different like factors. For the random forest models, we have different factors to take into consideration, so which is like multiple decision trees, future randomness with the random subsets of each splits. And then we have the non-linearity, which capture the complex relationship in the data sets. And then the performance, we had like, for the root mean square error, we had the values right here. It's like 0.01, and the ME was also close enough. So to just strengthen our analysis, we conducted like we look at the residual analysis as well in both ends. So there was actually on the regression reducible, we observed like a normal distribution, which indicates basically unbiased prediction, and which suggests basically a consistency across the board on the data sets. And then also it tells us that the price range across the board was good. So that tells us basically the pattern, there was no systematic like error in the distribution of the data. And on the feature of like why the feature importance, basically the top factor, the quality of the data, the above ground living area, and then the total base square feet, and then the neighborhood and the build. Those are the key factors that actually like show the importance features in the data set. So the dimension reduction, why do we actually like have to worry about like the dimension in the data set? Basically it's to just preserve the information, and then we had a 95% original variation, which explains actually that all our information was well contained. So that was actually good. And then the model interpretability was actually understanding among like the different uh, features that we looked at. And then here you can observe like the different comparison models between the ridge and then the random forest. As you can see, the ridge actually had more. So the insights, that we had more insight on the model performance here. So basically, in a nutshell, what did we learn? We learned that the ETS outperforming the ARIMA for the first or for the retail forecasting program. The regression, the rig control multicollinearity, while the random forest capture the non-linear aspect of the data sets. And then with that, we had to use like the log transformation for the pre-processing to stabilize basically like the variance and improve the prediction accuracy. And then the PCA maintained a 95% information while reducing the future account. So this basically concludes our presentation, and then this is actually time for question and session. And thank you very much for allowing the time for the presentation. Thank you.